So let's consider the rotation of a rigid body about an axis defined by the unit normal vector n, which is normal to the plane of rotation of point P. Point P has position vector r, and r makes an angle phi to n. The position of P is theta, and the velocity vector tangent to the circle v is dr dt, or r dot. Now the magnitude of v is ds dt, where s is arc length around the arc, which would be r d theta dt. Now r here is the radius in the plane of rotation of the point P, which is therefore r sine phi. So therefore ds dt equals little r theta dot sine phi, where little r is the magnitude of the position vector r, and theta dot is the magnitude of the angular velocity vector omega. So the magnitude of the velocity equals the magnitude of the radius times the magnitude of the angular velocity times sine of phi, where the angular velocity vector has magnitude theta dot and direction n. Now, if we make the construction omega cross r and take its magnitude, then its magnitude would be the magnitude of omega times the magnitude of r times the sine of phi, which is ds dt, which is the magnitude of v, as we found above. Therefore, given that v is perpendicular to the plane of omega and r, we can therefore write that omega cross r equals ds dt times the unit vector v divided by the magnitude of v, but ds dt is the magnitude of v, so therefore omega cross r is v. And so we now have a vector definition of the angular velocity omega in terms of the position vector and the velocity vector. So v, which is r dot, is omega cross r, where the magnitude of omega is theta dot. The acceleration a is dv dt, which from our previous slide is d dt of omega cross r. Applying the product rule is d omega dt cross r plus omega cross dr dt, which is d omega dt cross r plus omega cross v. And d omega dt is alpha, the angular acceleration vector, so we get that a is equal to alpha cross r plus omega cross v. So the angular acceleration alpha also acts along the axis of n, and its magnitude is omega dot or theta double dot. Now, making use of, again, v equals omega cross r, that gives us that a equals alpha cross r, and substituting omega cross r here, we get omega cross r. And so looking at the direction of this vector, we can see that these are the tangential component of a, and that this term here is the radial component of the acceleration.